Download this code from codegive.com, link in the description below. Secure Coding for Beginners, a step-by-step guide. Secure coding is a practice that involves writing software in a way that protects it from vulnerabilities and attacks. This guide will help beginners understand the principles of secure coding and provide practical examples to avoid common mistakes. Step 1. Understand common vulnerabilities. Familiarize yourself with common vulnerabilities, such as 1. SQL injection occurs when untrusted input is used in SQL queries. 2. Cross-site scripting, XSS, happens when an application includes untrusted data in its web pages. 3. Cross-site request forgery, csrf, an attack that tricks the user into executing unwanted actions. 4. Buffer overflow, occurs when a program writes more data to a buffer than it can hold. 5. Insecure direct object references, when an application exposes a reference to an internal object. Step 2. Input validation. Always validate and sanitize user input to prevent injection attacks. Example, SQL injection prevention. Using parameterized queries with prepared statements in Python with SQLite. Python. Import SQLite3. Connect to the database. Con equals SQLite3.connect, example.db. Cursor equals con.cursor. User input. User underscore ID equals input, enter user ID. Secure query using parameterized statements. Cursor.execute, select asterisk from users where ID equals, user underscore ID. Result equals cursor.fetch all. Print, result. In this example, the user input is safely passed to the query without direct inclusion, preventing SQL injection. Step 3. Use secure authentication. Implement strong authentication mechanisms, such as using hashed passwords and multi-factor authentication, MFA. Example, password hashing. Using Python's bcrypt library for password hashing. Python. Import bcrypt. Hash a password. Password equals bsuper_secret_password. Hashed equals bcrypt.hashpa, password, bcrypt.gensalt. Verify the password. If bcrypt.checkpa, password, hashed. Print, password matches. Else. Print, password does not match. This ensures that even if the database is compromised, the passwords are not easily recoverable. Step 4. Implement proper authorization. Ensure that users have the necessary permissions to perform actions. Example, role-based access control, RBAC. Python. def_check_access, user_role, required_role. If user_role equals required_role. Raise exception, access denied. User_role equals guest. Required_role equals admin. Check_access, user_role, required_role. This function checks if the user's role matches the required role before allowing access. Step 5. Use HTTPS. Always use HTTPS to encrypt data in transit, preventing eavesdropping. Example, enforcing HTTPS in a web application. In a Flask application. Python. From Flask import Flask, redirect, request. App equals Flask, __name___. Add app before _request. Def enforce _HTTPS. If not request is _secure. Return redirect, request.url.replace, https:// at uproot, / def index. Return hello, secure world. If ___name ___ main ___. App run, SSL _context ad hoc, for testing, use a proper certificate in production. This code redirects users to the HTTPS version of your site. Step 6, regularly update dependencies. Keep your libraries and dependencies up to date to avoid known vulnerabilities. Example, using pip to check for outdated packages. Bash pip list outdated. You can update packages with bash pip install upgrade package _name. Step 7, error handling. Avoid revealing sensitive information in error messages. Example, secure error handling. Python. Try some code that may cause an error. Result equals 10/0. Except zero division error. Print, an error occurred. Please try again later. This prevents attackers from gaining insight into your application structure. Step 8, conduct security testing. Regularly test your application for vulnerabilities. Example, using a static code analysis tool. Integrate tools like Bandit for Python. Bash pip install Bandit. Bandit R. This scans your code for common security issues. Conclusion. Secure coding is essential for protecting your applications from attacks. By following these steps, you will create more secure software and reduce the risk of vulnerabilities. Remember, security is not a one-time task but an ongoing process. Always stay informed about the latest security practices and threats.